We are about to start Chapter 5, and before we do that, we're going to go over a few skills that are going to be necessary in Chapter 5 that we've already learned. So a couple of review problems. First of all, we'll start off with some factoring from Lesson 03. Number one is just what I call basic factoring. Set up two binomials, and the two numbers that multiply to give you negative 24 would be positive 8 and negative 3. So then solving this, we'd have to set x minus 3 equal to 0, and we would get 3. We would set x plus 8 equal to 0 and get negative 8. So there's your two solutions on number one. Number two, again, I call this basic factoring. Two numbers that multiply to give you 28 add up to give you negative 11 would be negative 7 and negative 4. Setting each factor equal to 0 would give us x equals 4 and x equals 7. Number 3 is a little bit harder. So because we have an a value in front of the x squared, I've taught you how to take it and send it to the back. If we do that, it'll give us x squared minus 9x minus 10 equals 0. Now that we can do the basic factoring with a negative 10 and a plus 1. But now you have to make up for sending the 2 to the back by dividing both of these by 2. So you can see how we get x minus 5. Since 1 is not divisible by 2, we put the 2 in front of the x. So there's our factoring. And so we get answers of negative 1/2 and positive 5. Number 4, instead of sending it to the back, let's just use number sense to factor this. I'm going to go with a 5x and a 3x, because if we multiply those first terms, we get 15x squared. I'm also going to go with a positive 4 and a positive 2. And here's how I know this is correct. If I check the outside terms from FOIL, that gives us 20x. If I combine the middle two terms, the inside terms, that's 6x. If you combine those, you get 26x, which is the middle term of the trinomial. Therefore, our solution would have to be x equals negative 2/5 and x equals negative 4/3. Number 5, this one gets done a little bit differently because there's a GCF. The GCF is 2x. If we take 2x out of everything, it leaves us with x squared minus x minus 6. Then that trinomial can be broken down into x minus 3, x plus 2. And so now we're going to have three solutions. You can see how we're going to get the negative 2 and the positive 3. But if you set 2x equal to 0, that would give you an additional answer of 0. So three solutions to number 5. Number 6, we can also take the GCF of 6x out of everything. Leaves us with a 2x squared plus 13x minus 7. This gives us a trinomial that we can break down. I'm going to put a 2x and an x at the beginning of both of those. And then we'd have to put a plus 7 here and a minus 1 there. And so our solutions will be x equals 0, x equals positive 1/2, and x equals negative 7. So that's a little bit of a review on factoring. Number 7, it talks about how a rocket is projected vertically into the air, and its distance in feet after t seconds is represented by this equation. Find the amount of time that the rocket is in the air. Probably the best way to do this is to use a graphing calculator. So I have entered the equation into the graphing calculator. Now, if we graph this, we get a graph that doesn't look very good. Now, the reason for that is because the window is not set up appropriately for our problem. X represents the distance in feet. And I'm going to guess that, we're not going to go negative, so I'm going to try negative 5 feet to 15 feet. We'll see if that's enough. And then we'll go by ones. But the vertical scale, I'm going to guess that definitely needs to change. Let's try going negative 25 up to 100. Increments of 25. Let's see what that graph gives us. All right, well, you can see the rocket going up and coming back down. We just didn't go up high enough, so this rocket is shooting up pretty high. So let me go down here and increase this up to 500. That looks pretty good. Looks like we need to go a little bit further up. So let's go 600. Maybe I'll change my increments to 50. It makes it easier to see the increments. And there's the graph of the rocket shooting up in the air. Now, what does the question ask? The question asks, find the amount of time that the rocket is in the air. So, at 0, 0 is when the rocket gets launched. And so when it hits the x-axis right down here is when it lands. So if we find that point, let's try maybe 12 seconds. Look at that, right on the dot. So 12 seconds it hits the ground, so it's in the air for 12 seconds. Now, how could we have done that algebraically? We could have put 0 in for s of t. We could have factored a 16 out. Let's factor a negative 16 out. Negative 16t out, that leaves us with t minus 12. Setting both of these equal to 0, you can see that we're going to get t equals 0, and we're going to get t equals 12 seconds. So there's the algebraic solution. Next, number 8, a review of finding missing lengths. Well, you can see on number 8, we have a right triangle. And so to find that missing side length and the missing angle measures, we use right triangle trig. So Pythagorean theorem, 35 squared has to equal 18 squared plus letter c squared, because this is length c, because it's opposite of angle c. So 35 squared minus 18 squared gives us that. We have to square root this answer, and that gives us roughly 30.0. Now, to find the missing angles, A and C, we can use sine inverse of 18 over 35 to get angle A. So if I do that, 18 divided by 35, just want to check my mode to make sure I'm in degree mode here. I am. That gives me angle A to be about 30.95 degrees. Which means that angle C would have to be the complement to that, adds up to 90 degrees. And that would have to be 59.05 degrees. All right, number 9, we have to use the law of sines. And if we use the law of sines, we'll say the sine of 33 degrees divided by 14 equals the sine of 115 degrees divided by length b. And if we cross multiply and divide, 14 times the sine of 115 divided by, let's see here, divided by sine of 33 gives us an answer of about 23.3. And then we also know that angle A has to equal, if we take 115 and 33 degrees, we get 32 degrees for angle A. One more thing to find, and that would be length A. Got to find this right here. So we use the law of sines for that. So the sine of 32 degrees divided by length A equals the sine of 33 over 14. Cross multiply and divide. 14 times the sine of 32 divided by the sine of 33 gives us about 13.6. Number 10, looks like we got a right triangle, so we know that angle L would have to be 40 degrees because that's the complement of 50 degrees. And now we need to find length K, and we also need to find length L. So let's use trig to figure out length K. The sine of 50 degrees would have to equal 16 over K. So on my calculator, I take 16 divided by the sine of 50. And that gives us 20.9 approximately. And then to find length L, I would say the tangent of 50 degrees would give me 16 over length L. So on my calculator, I'll take 16 divided by the tangent of 50. And that gives me 13.4. And number 11 is not a right triangle, so this is a law of cosines problem. I will solve for length K first. And so if I do that, I will get the measure of length K to be oh, goodness sakes. Let's put a multiplication symbol in there. That looks a little bit better. 10 times the cosine of, that should be a 10, times the cosine of 62 degrees. This gives us 83.3. But then we have to square root that to get about 9.1. And now we got all three sides. We can find the missing angles. Now, can you tell that angle L is going to be the largest? So I'm going to find angle J using the law of sines. So the sine of angle J divided by length 7 has to equal the sine of 62 degrees divided by length 9.1. So 7 times the sine of 62 divided by the 9.1, and then we do sine inverse of that, and we get 42.6 degrees. That's angle J. And then angle L, if we try to find that, would be 180 minus the 62 minus that, would give us an angle of 75.4. To find the exact value of the cotangent of 420, I would try to find the cotangent of 60 degrees because 420 and 60 degrees are coterminal. And this would be equal to 1 over the tangent of 60 degrees. And since I know that the tangent of 60 degrees is square root of 3, I would give my final answer in a rationalized form like that. Cosine of 7/4 pi, that's just off of the unit circle. This is the x value at 7/4 pi, which should be positive root 2 over 2. Secant of 10 pi over 3, let's find a coterminal angle with 10/3 pi. 4/3 pi is coterminal with 10/3 pi. They're 2 pi apart from each other. And so then I can find the cosine of 4/3 pi from the unit circle. That's equal to negative 1/2. And then to simplify this, we would get negative 2 for a result. Number 15, tangent of 480. Let's do a coterminal angle with 480. So if we subtract 360, it would give us 120 degrees. This is on the unit circle, and the tangent at 120 degrees is equal to negative root 3. Last two problems, cosecant of 2/3 pi is equal to 1 over the sine of 2/3 pi. And your last two answers for 16 are 2 root 3 over 3, and number 17 is 1/2. Hope you'd enjoyed doing some review problems. Starting chapter 5 tomorrow.